Hi. Hey everyone. This week we will start to talk about a new topic called magnetism. Magnetism is the physics about magnet or electromagnet. So you probably are familiar with some magnets before. So let me show you what's a magnet. For example, the magnetic sticker that you have on your fridge, that's a magnet. All these little black pieces, they attached to the fridge, the surface of the fridge, due to the magnetic force. And if you go on Amazon and type magnet, you can probably get some we call the bar magnet and the horseshoe magnet. These two are also the common magnet that you will see. Maybe not in your life, but in some industry, you may see this type of a magnet. So all of this magnet, type of magnet, they all have two poles or two polarities. One is we call the south pole, one is we call the north pole. So as you can see, this is a north pole, this is a south pole. If you put two north poles next to each other, they're gonna repel. See, if you put two south pole, and they will repel as well. If it's south and north, they're opposite, then they will attract. So this is a magnetic force. All right. So before we before we jump in and talk about magnetic force, magnetic field, we need to employ a new physics quantity to describe a magnet. So similarly, so for example, in electrostatics, we use Q to describe the charge. But for a magnet, we also need a new physics quantity to describe this new magnet. Describing a magnet can be very tricky, and this is why. So in electrostatics, you can have a positive charge, you can have a negative charge. For example, electron is a negative charge, and it is okay that one electron carries only negative charges. However, in magnet, this is impossible. You will never ever find a magnet which has only the south pole or the north pole. South pole and north pole, they always come together. So for example, if you take a bar magnet, and then you break the bar magnet in the middle, what you will get is not south pole and north pole separately. What you will get would be two magnets. Because at this age, a new north pole and a new south pole will appear again. And you can keep doing that. You can keep breaking this little this two magnet in the middle. And once you break it down the center, what you will get is not south, no south, like south pole, north pole, south pole, north pole. Instead, you will get just four magnets, and each of them, they all carry south pole and north pole all together in one piece. So since it is impossible to separate the poles, therefore, when we use the physics quantity to describe a magnet, we cannot say, oh, this magnet is a south pole. It's a positive 2 south pole, and that magnet is negative 2 north pole. It just doesn't make sense anymore. So to describe a magnet, we need to use a vector. So this is what we use to describe a magnet. We call it magnetic moment. So it's somewhat like a charge, but charge is used to describe a charged particle. Magnetic moment is a physics quantity you will use to describe a magnet. And this magnetic moment, it must be a vector because we need some strength to talk about its, like how strong it is. But we also need a direction. We also need a direction to tell people its polarity. So for example, if I have a bar magnet, as in this picture, This bar magnet has a south pole here and a north pole here. And to tell people that my magnet is oriented in this direction, I will say, okay, this guy has, instead of mu, let's use m. This guy has a magnetic moment m, which has a strength, I don't know, m, let's call it m, and with the direction pointing this way. This direction is determined by pointing from the south to the north. Okay. So this is how you describe a magnet like this. You use magnetic moment. You will use this. You will give this magnetic moment a strength, and also give it a direction where the direction is pointing from the south to the north. The unit for magnetic moment is what we call A square, ampere square, times m, times meter. As you can see, we don't really use this magnetic moment so much, such that we don't have a specific name for its unit. Right. And so now we know how to describe a magnet. We use magnetic moment to describe it. And now the next step is I want to tell you a few ways to make a magnet. So one way to make a magnet, we call such a material ferromagnet. So this is how you can do it. So first, you want to put an iron between two external magnets. This iron had no magnetism at all before. And then you can heat up this iron. And once you heat up this iron, the little magnets, like spins in this iron, they will reorient. And once they reorient, and you can remove this heat, you can remove this heater, and then when it cools down, this iron will just automatically become a new magnet. This is what we call the ferromagnet. So exactly how does this work, like microscopically? So here you can see, excuse me. Microscopically, you can see why this, how this happened from the setup picture. So iron has a lot of iron atoms inside. And all these iron atoms, they all carry spins. So what's a spin? Spin means, spin is like charges, like intrinsic magnet carried by each iron carried by each iron atoms. So you can imagine like there's a lot of iron atoms here, and they all carry some intrinsic magnet we call spin. But their spin may orient a different way. They have the same strength of spin, but they just orient differently because there's no favored direction for them. So for example, this power pointing to the left, this power pointing to the right. If you sum up all of them, the net spin, sum up all of them, it will be 0 because it's a direction, right? It's a vector. If you add up all of them, they will just all add up to be 0. So that's why usually if you have an iron metal, it doesn't show any magnetic properties because it just all canceled out. However, if you heat up once you heat up this iron, they get more energy, then they can freely move around, and the spin can freely spin around. And when this spin, they can freely spin around, and you put this spin, like all of this little spin magnet, in this external magnetic field, right? This is the magnet, this is the North Pole, this is the South Pole. So say if we look at one spin, say if I have a spin in this metal, and we know the spin is a little magnet pointing from south to north, then this south part will be attracted to this north, and the north part will be attracted to the south. It will be attracted to it, it will be attracted to it. So when this happens, you can imagine this little spin or this little magnet, it will freely, you'll want to reorient itself to this direction. Because the north pole want to attract it to the south, and the north pole want to attract to the south, and south want to attract it to the north. And you can imagine all the spin in this iron, they will all do the same. No matter what's its original direction, eventually they will all want to orient themselves in this way. And once they all orient themselves, so you can see they will all start to orient at the same direction. Once they are all done, we can remove the heater, and the whole structure will cool down and the spin will be freezed at that position. So once you're done with that, you can see all the spin in this magnet, all the spin in this iron pointing at the same direction. And it makes this entire iron object become a huge magnet because they are all pointing at the same direction. And this magnet has a south pole here, has a north pole here, because this is aligned by this external magnets. Okay, so this idea is it's probably a lot. It's a lot of process. Try to think about it carefully. Like make sure you do understanding why this orient in this way. What does the spin do in this case and in that case? So feel free to pause the video and to make sure you do understand this process. All right. Another way to make a magnet is simply induce some current. When you have some current, the current will generally create a magnetic field. We will talk about magnetic field later, but here the idea I want to come across is once you have a current, the current can create a magnetic field. If you have a current, you somewhat have some kind of magnet. If you can further wind your current wire as a solid, like around a cylinder, okay, and then your wire, this wire coils will look like this, right? This kind of shape we call it solenoid. And when you wire your current wire like a solenoid, when you do that, this part of solenoid will behave like a magnet, where this is the north pole and this is the south pole. If you put an iron in the middle, then this iron will be driven. We will turn this iron into a magnet. But if you don't have this iron, even the coil, the solenoid itself, will behave like a magnet. This kind of magnet we call electromagnet because it's driven by electricity. For example, MRI is such a case. MRI has a lot of coils, like with current running through it, and therefore it will create a strong magnet, like all around, like in the center, and some magnetic field in the space.